Hello guys, today I'm going to design the footing for this building using SAFe software. This building is constructed in the tab software. So for designing the footing of this building, just we have to get some data from the ETAB software. To get the data like as column dimensions, columns load, and so getting these data, so then just go on Model Explorer and click on Model button. After that, click on Structural Objects, expand it. Now go on Columns, expand it, and check the dimensions of all columns one by one by clicking on column. Here you can see the dimension of column 1 is 500 into 500 mm. Click on Cancel. In this way, change the dimensions for the all 16 columns one by one. After checking the dimensions of columns, go on Tables, just click on Analysis and expand it. Expand the results. After that, go on Frame Results and expand it. After expanding it, click on Column Forces to check the forces of column acting on the story 1. Right click on Story, click on Select Story 1. Right click on Load Case, select here Dead Load. Right click on Stations and make the short ascending option check. Now load the values for corresponding column which denotes the dead load. Here dead load for C1 column is 1681.8 kilonewton. In this way, change the load case to live load and sort it in ascending order. Now note the loads for column C1 to C18, the value of live load. After the noting down all the values, just cancel this tab. Now we have to check the materials. So go on Define Material Properties. Define Section Properties, Frame Sections. Click on any sections. Just click on Modify Show Property. Here you can see the C500 500 column M14 concrete is used. Now click on Modify Show Rebar. You can see the bar of HYST 415 has been used to design this structure. Click on Cancel button. Again click on Cancel. Now we have the proper data to design our footing for this building. So just close the software. Take the value of soil bearing capacity of 300 kN per meter square. Take the allowable settlement 1 centimeter. So calculate the subgrade modulus from these data. The subgrade modulus will be 300 upon 1 centimeter, which will be equivalent to 3 into 10 to the power 4 kilonewton per meter cube. Calculate the length of column strip, which will be 0.25 into 18 equals to 4.5 meter. But there is no provision for strip width, so choose the lesser value. So take the width of the strip 4 meter. Now click on File button. Click on New Model. Change the units to metric. Click on OK button. Design code IS 456 2000. Now click on design preferences. Minimum cover slabs. Take the minimum cover slab of 50 mm for top and 50 mm for bottom. Give the preferred bar size 22 mm. Now click on OK button. Again click on the option grid only. So calculate the total grids. The minimum value of grid should be 1 meter here. So total 18 meters are in x direction and 18 meters are in y direction. So number of grids in x direction will be 18 meter plus 1 is equal to 19 meter. 19 grids or number of grid lines in y direction will be also 19. Grid spacing 1 meter, which is the least count of grids. Assign all those values and click on OK button. Now grids are open. Here we are going to 2-meter offsets. Going to take the 2-meter offsets for the slabs from the column. So to assign that, go on edit. Choose the material type rebar. Weight per unit volume equal to 77. Modulus of elasticity 2 into 10 to the power 5. Minimum yield stress 415 and minimum tensile stress 485 Newton per mm square. Click on OK button. Now again click on OK button. Now define slab properties. Add new property. Slab thickness. Give the value of 1200 mm. Click on OK. Again click on OK. Material slab. Now click on column properties. Add new properties. Property name column 1. Column 500 into 500. Material M14. 500 mm. 500 mm. Click on OK button. Modify the slab property data and in the type select mat because we are going to use mat footing here. So change the type to mat and give the thickness 1200 mm. Click on OK button. Now again go on define column properties. Add new column. Column 600 to 600. Material M40 with the value of 600 600. Column shape will be rectangular. Now just click on OK button. OK. For size upgrade, go on define size upgrade properties. Modify show property. Give the value of 3 into 10 to the power 4, which has been calculated. Click on OK button, again click on OK button. Now go on define load combinations. Click on add new combo. In combo 1, for unlimited design selection, give the dead factor of 1.5, and for live load give the factor of 1.5 also. Check on instant ultimate, click on OK button. Again click on add new combo, add second combo, click on combo 1, give the scale factor of 1. Here choose the live load name and give the scale factor of 1. Select service loads, click on OK, again click on OK button. Now draw slab areas, slab, mat footing, let's type straight line, draw the slab, press escape button. Now select the footing, go on edit areas, expand shrink areas, give the offset value of 2 meter, which is 2000 mm. Click on OK button. Now draw columns. Select the type of object column. Here column of 500 into 500 mm is not shown. So just again go on define column properties, add new property, give the name column 500 into 500. Material choose M40, 500 into 500. Rectangular column, click on OK button. Again click on OK button. Now go on draw columns. Here select column 500 into 500. Property above none. Property below property below none. Property above column 500 into 500. Height below 0. Height above, give the value of 2 meter. Now just draw all the columns 500 500 dimensions. Each columns are at 6 meters, so on 6 meter place other column. Escape button. Now again go on draw columns, select column, property below none, property above, column 600 into 600. Again draw the column of 600 into 600. Now press the escape button. So all the columns have been positioned according to the drawing in the tabs. So now we have to draw the strips of 4 meter. So just go on draw design strips, strip layer A, give the value of 4 meter. Now draw the column. All the design strips in X direction has been drawn. Now we have to draw the strips in Y direction. Select B, strip layer. Now draw in Y direction. Right click, right click, right click. All the strip has been drawn. To see the strips, click on set display options. Check all these options, click on OK. You can see all the strip drawn. To disable these, again go on set display option and check all these options, click on OK button. Now we have to assign the loads for all columns, footings and the strips. To assign the load, choose the footing. Before before doing this, we also have to assign the load data. So just select the footing has been selected. Now go on assign support data, soil properties. Here choose soil, click on OK button. Now support data has been assigned. We have to now assign the load. So for assigning loads for columns, choose columns points one by one and define dead and load drives for each columns. So for column C1, click on midpoint of column Here you can see one point has been selected. So now go on assign, load data, points load. Here select dead load, give the value of 1681.9, which we have noted from the ETAP software from our building model. Now size of load, give the dimensions of 500 into 500. Click on OK button. Now again select this point. We have to assign now live load. The value of live load is 737.2 for column first. The value of 500 into 500, which is already. Click on OK button. In this way, similarly define the point loads, dead and live load for the columns by using the same process I have done. Assign the point load for all these columns. One point has been selected. Now go on assign support data, load data, points load. Give the value of 2813. Click on OK button. Again select this point. One point selected. Assign. While selecting, make sure that you have selected only points, not any extra. So go on support data. Click on live load. Select the live load of 1385.8 kilonewton. Click on OK button. Now first assign the values of column 3. Press Ctrl J to get the PCA previous selection. Hence the dead load and live load for all the columns has been defined. Now we have to define the reinforcement bars for footings. So just right click on footings. Here you can see the footings area has been linked. So go on design, select rebar material. Choose the rebar material of HYST 415. Click on OK button. Again click on OK button. You can see the loads rebar materials for columns has been predefined as well as D415. The rebar material for all the columns are predefined, so we don't have to select the rebar material for the columns. Now we have to select the rebar materials for strips. So select this strip, right click on this strip. Now you can see this strip is the blinking. Now go on design in rebar material. Select the rebar material HYSD415. In this way select for all strips to the rebar material. Now rebar material for the all strips has been defined. Click on OK button. Now run for analysis. Go on run and click on run analysis. Now you can see the displacement value for all the elements on the footing after running analysis. Now click on run analysis and design. Click on display. So punching shear design. You can see all the values of punching shear is less than 1. So our design is safe towards here. To see the extended view of this footing, just click on set display. Now here choose extrude view and mark it. Click on OK button. Now just click on 3D. You can see the 3D extrude view of our footing. Now go on set display as option, uncheck extrude view and click on OK button. Click on XY to set plan view. Now we have to interpret results. So for interpreting results, go on display. We have to see the strip forces. So click on show strip forces. Select the load case yes. If you want to see the movement in components, just click on movement in layer 1. So values in diagram, click on apply. Here you can see the movements along x-axis. This value denotes the maximum movement at this column. To see the movement for layer B, click on layer B, uncheck layer A, click on apply. Now you can see the movement along layer B. Now click on close button. Now go on display, so slab design, click on impose minimum reinforcing, so that according to IES code you can see the minimum reinforcing for slabs along layer A. Click on apply. You can see the minimum reinforcing along layer A. To see the minimum reinforcing along layer B, check the option layer B, click on apply button. You can see the minimum reinforcing along layer B. Just close it. Now go on display, so select forces stresses. If we want to see the maximum moment, click on mm max. For that case, you on dead, click on apply. You can see the value of maximum moment, which is 10 to the power 3. Here you can see that E plus 3 means 10 raised to the power 3. Now click on close button. You can see the value of moment at each point. Go on display, so crack width, we have to see the crack widths on slab bottom faces due to all loads applied. Now click on apply button. Due to dead load, these cracks will be found on the bottom of the footing, which is so minimum that could be neglected. It is in the value of 10 to the power minus 3, which is in mm. So these values could be neglected and could not be seen by eyes. To see the cracks on top surface, click on slab top surface, click on apply. You can see the cracks developed on top surface.